Homework 4.4, Exponential and Logarithmic Equations, Video 2. Homework due Friday, May 29th at 11:59 p.m. Let's take a look at another exponential equation that we can solve using equal bases. Now, one of the catches to this is figuring out, can we use equal bases to begin with? Because sometimes the answer will be no, in which case we'll use a different technique, a technique that will be introduced in the following video. But when you're solving an exponential equation, you should at least ask yourself, can I get equal bases? Can I get equal bases? The one strategy is to try to write the larger base as the power of the smaller base. So for example, is 125 a power of 25? And that's an easy question to answer with just a little bit of button pressing on a calculator. Obviously, 25 to the first power would not be the correct power because 25 to the first power is 25. We want 125. So the natural thing to try next would be 25 to the second power. But it wouldn't take you long to figure out that that's 625 and that's too big. So I cannot easily write 125 as a power of 25. Because the power that it is between 1 and 2, which means it's a fraction or a decimal, and there's an infinite number of fractions and decimals between 1 and 2. So the answer to is 125 a power of 25? Not easily. It is, and if you text me or send me a message and ask you, well, what is that power? Then I'll find out, or you can just try to solve this equation on your own. And it'll answer the question, 125 is what power of 25? But I'll just leave that for you to do in case you're curious. But what happens if you're trying to get equal bases and you can't get them that easily? Well, then you ask yourself, can I rewrite both bases? Both bases as powers of a new base. In other words, I can't write one as a power of the other, so can I write both of them as powers of a new base? If you're going to go down that path, you should start with the smaller of the two. For example, 25, it should be pretty transparent that that's 5 to the second power. In other words, I can write 25 using a base of 5. Can I write 125 using a base of 5? Now, you may already know yes and even know what that power is, but this is where a factor tree and just pruning off 5s is handy. Use a calculator if necessary. 5 goes into 125 25 times. That's a good sign. 5 goes into 25 5 times. So 125 is 5 to the third power. So for this one, I can solve it, but I'm going to have to rewrite both sides using base 5. So how would that work? Well, the 25 is going to be rewritten as 5 squared, but here's where you have to be a little careful. The 25 already had a power on it. That means that the 5 squared will have the same power. So 5 squared to the x plus 3 power. And the same thing with the 125. 125 is 5 to the third power, but the 125 already had a power on it. The power on it was x minus 1, and so the 5 to the third power has a power of x minus 1 on it. Now, at this point, we kind of have same bases, but we still technically don't. You could argue that the base on the left side is still 25, or at least the base of this power is still 25, and the base of this power is still 125. I want both of these saying 5 to a power, not 5 to a power and then another power. So we need to get out an exponent rule. Luckily, we have one. There are exponent rules that say, there's an exponent rule that says when you have a power raised to another power, you can multiply. And I'll have to do it on both sides. Now, in this case, multiplication is going to invoke the distributive property. So we have to distribute the 2 across the x plus 3. 2 times x is 2x, plus 2 times 3 is 6. And on the right side of the equal sign, same story, different verse. Same song, get different verse. 3 distributed across x minus 1. 3 times x is 3x, minus 3 times 1 is 3. And at this point, it is crystal clear that both sides are powers of 5. Not, I think I'm a power of 5. Well, 2 is a power on the 5, but x plus 3 is a power on 25. All that's gone. There is only one power over here, and it is on a 5. Same thing there. So we can use the one-to-one property of exponential functions, but the net result of that is you cancel the bases and equate the exponents. Now we're not quite out of the woods yet, we still have something to solve, but this caliber of equation is a skill you should have had coming into this class. We're solving an equation, there's too many x's, get rid of one of them. I always choose the lesser of the two. That way that side will cancel, and on the other side it should remain positive. 3 minus 2x is 1x, well that's convenient. We still have a 6 on the left and a minus 3 on the right. And now the only other move I need to get the x by itself is to get rid of the minus 3 with the plus 3 on both sides. And just like that, x is equal to 9. You could actually check it by going back to the original, but I would have a calculator handy. The claim is 25 to the 12th power, 9 plus 3, equals 125 to the 8th power, 9 minus 1. You can check both in a calculator, and they should be equal. So to summarize, when you're solving exponential equations using equal bases, rewrite one or both sides until you have a power of the same base on both sides. That may require doing some shenanigans like this. It may bring up a power raised to a power scenario where you have to multiply. But once you have one base and one power on each side, cancel them and go about your business.